Thanks for introduction. Hello everyone, welcome to my talk. And I'm Junkyung Kim from KAIST, and today I'm going to present exciting work, HearMeOut, detecting a new voice phishing activity in Android system. And this work is collaboration work with Jiwan Kim and Seong-il Lee and Yongdae Kim and my advisor Suel Son. And in the USA, voice phishing caused $20 billion financial loss in 2020. Also in 2021, about $720 million is lost due to the voice phishing in Korea. And recently, the amount of voice phishing is rapidly increasing. And this is due to a new powerful voice phishing method. And before I explain the new voice phishing method, let me briefly explain the traditional voice phishing method. And using the non-face-to-face communication nature of the telephone communication, the attacker calls the victim and impersonates a person like a bank agent. If a victim believes the attacker as a bank agent, attacker can extort the victim's money. And I will explain the evolution of the new voice phishing in the next slide. And the first purpose of the attacker is to install a phishing app on victim's mobile device. Usually, attacker offers an attractive ROAN service via SMS. The SMS offers a bank app download URL. When the victim installs the phishing app using the given URL to get a ROAN service, the attacker can use this app for voice phishing. When the victim calls a legitimate bank number, the installed phishing app blocks the outgoing call to the legitimate bank. In addition, the phishing app makes a connection to call to the attackers. The victim is on the phone with the attacker, but the victim believes the attacker is a legitimate bank agent because he thinks the phone is connected to the bank. And this new attack is very effective to deceive victim. According to Korean police investigation, the average financial loss due to the new voice phishing campaigns are 10 times greater than traditional voice phishing. And for summary, there are two characteristics of the new voice phishing attack. And first, attacker uses an Android app for phishing attacks, and the installed voice phishing app can redirect the victim's outgoing call to the attacker. Instead of traditional voice phishing, use the victim's incoming calls. And I briefly summarize the contribution for the new voice phishing attack. And first, we analyze 2017 Android phishing apps, and we figured out the main three voice phishing functions: call redirection, and fake screen, and fake voice. In addition, we analyzed the current defenses limitation of the new voice phishing attack. And the existing defense has two main limitations. And first, they don't have enough information to detect the voice phishing app and its behavior. And second, voice phishing app can bypass the defense. And based on the above analysis result, we developed the HearMeOut, which is a runtime phishing behavior detection using Android system level information. We implemented HearMeOut as an Android system service by modifying the Android OS. And last, we conducted a system evaluation and user study for the effectiveness of HearMeOut and the effectiveness of the new voice phishing attack. Let's start with the phishing app analysis. I briefly explain how the three function works. And call redirection is the Android API that can change the outgoing call numbers. Let's watch the simple demo video for the call redirection. When a victim calls the legitimate bank, and please remember this call number, the installed phishing apps can redirect the attacker's number. As you saw, installed phishing app can change outgoing call number seamlessly. And also, fake call screen can change the displayed outgoing call number. When call redirection occurs, the phishing app shows an overlay to replace the outgoing call number. It will prevent the victim from recognizing the outgoing call number changes. At the last, when the call is redirected, installed phishing apps play a greeting voice of the bank's automatic response system. It makes the victim believe that they are connected to the legitimate bank. And here's the voice phishing demo using the three functions I just described. when the victim calls a legitimate bank number, the phishing apps redirect to the attackers. In addition, phishing apps display a fake call screens.
Welcome to Wells Fargo. This call may be monitored or recorded.
And last, phishing app plays a ARS greeting voice. And do you think the victim will be deceived by these phishing attacks? And I will answer this question in our user study sections. And here I introduce existing phishing defenses and its limitations. And first, there is a phishing aim and phishing behavior detection apps. And however, phishing defenses can only access limited static information of phishing apps. It could make a false positive and false negatives. And in the Android M-level system, defense apps can only know the coarse-grained information about the other apps. Android app can access the static information of other apps such as source code and manifest file. And they cannot access the API using information. Also, phishing app can hide the phishing code using a dynamic source code loading, so phishing apps defenses can only know the limited static information. It could make a false positive and false negatives for phishing app detection. And the second defense is Android API updates. Android fixes dangerous APIs such as call redirection more safe. However, phishing apps can bypass the Android API updates. They can use API before the update by using the low app API level. The call redirection API existing since Android starting version API 1. And in API level 29, Android updates the call redirection API to prevent abusing. And all Android apps have an API level if a phishing app uses an API level equal to or higher than 29. The phishing app must use the updated call redirection service. It makes phishing harder. But however, if a phishing app uses API level lower than 29, phishing apps can still use the call redirection API before the update. Problem is that phishing app can choose their API levels. And we collected 2017 voice phishing apps API level distribution. And 99.3% of phishing app can bypass the updated call redirection API, and 97.1% phishing apps can bypass runtime permissions. And here is a takeaway from the existing defense limitations. First, M-level defenses can only access limited static information. It can cause false positive and false negatives. And second, phishing app can bypass Android API update by using a low API level. And from the above analysis, we present HearMeOut, a runtime voice phishing behavior detection system in Android framework. And HearMeOut overcomes the limitation of previous defenses. HearMeOut enables accurate phishing behavior detection by monitoring the occurrence of phishing-related API calls at the Android system level. And we directly change the function of each API related to phishing functions, and HearMeOut is able to monitor abusive usage pattern of API regardless of phishing app's API level. And I will explain the HearMeOut's architecture overview. And Android Java framework is placed between the Android app level and Android runtime. And Android API implementation existed in the Android framework as Android modules. And we revised Android OS to add HearMeOut as an Android system service. Also, we revised the Android API modules related phishing function. And HearMeOut can monitor API core information in phishing-related Android APIs. When phishing apps calls Android APIs related to the voice phishing attacks, HearMeOut can block the API used for phishing. Also, HearMeOut displays a warning dialog to the users. And I will explain more detail about the HearMeOut architecture. And we modified the Android framework to register HearMeOut as a system service. And we revised the voice phishing-related modules such as telephones and views and broadcast receivers. And HearMeOut can monitor API core information advantage of HearMeOut than the existing work, it can monitor all API information used by installed app in runtime. And detectors is one of the HearMeOut modules. It can detect phishing behavior by comparing the original call number information and the final call number information. And broker blocks the phishing actions and it sends a warning to the victims. I'll briefly explain the detection rule in the next slide. And we analyze the difference between API usage between the 1,000 phishing apps and 1K benign apps. And phishing apps change entire phone numbers, but benign apps change and add only the necessary prefix of the call numbers. We'll believe that these API usage difference can only be detected at the system levels. And please refer to our paper more about detailed information. And we evaluate HearMeOut's accuracy and overhead. And the life cycle of phishing app is very short. We only use 12 phishing apps that are running at the time of the experiment. In our experimental result, HearMeOut successfully classified the behavior between given phishing apps and benign apps. And also, we compare the latency with and without HearMeOut. The average latency of HearMeOut is just 0.36 milliseconds, which is a negligible latency. And we measure the additional battery consumption due to the HearMeOut using Google's battery historian. As you can see, the battery consumption bar is almost the same. It means the average consumption is negligible. Also, we conduct a user study to measure HearMeOut's defense and voice phishing attacks. And there are two goals about our user study. First goal is how effectively the voice phishing attack can deceive victims. And we tried the voice phishing attack on the participant with the user deception study. And the second goal is measure the HearMeOut's defense effectiveness. And we compare the voice phishing attack result with and without HearMeOut. And we recruit 45 participants by hiding the original purpose of the user study. And we advertising our user study as an observation of telephone interactions. And we randomly assigned 45 participants into two groups. 23 participants assigned without HearMeOut, and remaining 22 participants conduct an experiment and with HearMeOut. We tried the voice phishing attack on the both groups. And here is our user study process. And we request the participant to call the Uri Bank Customer Center, one of the biggest Korean bank. Also, we request the participants ask about their loan information, such as loan interest rate and limits and repayment period. When participants make a call to the bank, the installed voice phishing apps redirects the call to the actor. And we hired the actor to play a role of the voice phishing attacker. We instructed the actor to impersonate Uri Bank agent and ask participants personal information. And specifically, the actor asked the 5 types of personal information, including the bank's account and social security number of the participant. In the group with using the phone with HearMeOut installed, HearMeOut stopped the call redirections and displayed the warning dialog to the participant. And here is the warning dialog for phishing app detections, and we give 3 options. Participants can hang up the phone and make a call to their input number and make a call to the redirect numbers. And here's the user study result, and 87 participants believe that the attacker was a legitimate bank agent, and they give their personal informations. And they say that they didn't feel anything strange about the phone compared to the benign call to the Uri Bank. Even some participant who already knows about this kind of phishing attacks, but he was deceived. And with HearMeOut installed phone, all participants did not call the redirect number. They choose to the call number they entered, regardless of their understanding of HearMeOut warning dialog. Only one participant stopped the experiment. It means that HearMeOut warning dialog can make participants safe. And here are the takeaways. And attackers try a new voice phishing attack using voice phishing Android apps. And this attack is quite effective. And in our user study, it shows an 87% of success ratio to deceive participants. And HearMeOut phishing apps can bypass existing defenses. And they are using low API levels bypass Android updates. We show that 99.7% of phishing apps can bypass existing updates for core redirection. And from the above analysis result, we propose HearMeOut, the first Android system-level voice phishing detection in runtime. And we show that HearMeOut effectively prevents voice phishing with negligible overhead. And here is the last slide. I'm about to graduate a PhD student, a PhD program, and I'm looking for a job. And I had experience about many top-tier conferences and publishing a paper as a first author, including NDSS and MobiSys. And I got an award-winning coding skills, and I got ACM ICPC competition bronze award in Korea regions, and I got Qualcomm Star Award from the CEO of Qualcomm for Jacobs. And thank you for listening to my talk.